And then everything about 6.3 and 6.4 is on the review. So let's look at number 1. So we have to find the component form of vector v with initial point 7, -4, and terminal point -6, 10. How do we find the component form? So it's just terminal minus initial. And remember, you just keep the first point with the first point and the second one with the second. So we have -6 minus 7 and 10 minus -4. So it's -6 minus 7. -13 and -4, 10 minus a -4. Minus the negative becomes plus, so it's 10 plus 4. 14. So that's our component form. Next, we have to find the magnitude. So our magnitude is our distance formula. But once we have our vector in component form, we can just take the first number, square it, plus the second number squared. So what's 13 squared? 169. And 14 squared?
196.
196. And 169 plus 196?
365.
365?
355, right?
So that is our magnitude. And then when you find the magnitude, you want to simplify as much as you can. I don't think we can simplify this radical here. So just make sure you simplify your radical if you can. Also, on the test, it's going to ask you to find the direction. Anybody remember how to find the direction? It's just the slope. So it would be y2 minus y1 over x2 minus x1. So we can find the direction of this point here. So we have our x1, y1, x2, y2. Plug everything in. 10 minus -4 over...
Isn't it the same thing as our component?
Yep. It will be, but just like in a fraction form. -6 minus 7. So we got 14 over -13. So that would be our direction, just the slope. Any questions on that? All right, number 3. Find A, which is u plus v. So we're just adding our two vectors together. So when adding it, you just want to be consistent. Keep the first with the first and the second with the second. So 2 plus -3, and then -5 plus 5. So 2 plus -3 is what? -1, and -5 plus 5? 0. We have to find u, 2 times u minus 5 times v. So when doing these, make sure you keep your order of operations. So we want to multiply before we subtract. So we have 2 times 2 minus 5, and then -5 times -3, 5. Distribute the 2 to both things on the inside. So this gives us 4, -10. And then I'm going to distribute the -5 to both things on the inside and change it to addition. So I have -5 times -3, which is 15, and -5 times 5, which is -25. And then I just add them together. So keep the first with the first and the second with the second. So 4 plus 15 gives us 19. Negative 10 plus negative 25 is negative 35. Any questions here? Alright, 5. We have to find the dot product. How do we find the dot product?
It's like foiling.
It's kind of like foiling. We just multiply the first ones together and the last ones together and add them. So 2 times negative 3 is negative 6. Negative 5 times 5 is negative 25. So it's negative 6 plus negative 25.
Negative 31.
Negative 31. And then 6, we have to find the dot product of 7u and 3v. So 7 times 2, negative 5. The dot product of 3, negative 3, 5. So what should we do first here? Distribute. So we have 14, negative 35. And then distribute. Negative 9, 15. Now we have to find the dot product. What do we do for the dot product?
Multiply the first.
First times the first plus the second times the second. So what is 14 times 9? Negative 126. Plus, what's 35 times 15? 525. So what's negative 126 plus negative 525? 659? 651? Negative 651. Any questions here? Any questions from this section? Ready for the next page? Alright, number 7. We have to find the angle theta between the given vectors. What's our formula to find an angle for our vectors?
Is it the dot product over the magnitude of u and v?
Awesome. The dot product over the magnitude of u times the magnitude of v, and that's equal to cosine of theta. So here we have to find the dot product and then the magnitude of each. So let's start with our dot product. We multiply the first times the first plus the second times the second. So this would be 6 times 4, which is 24, plus negative 2 times 8, negative 16. What's 24 minus 16? 8. So on top we get 8. Now we have to find the magnitude of u. To find the magnitude, we square the first, take the square root, square the first, plus square the second. So this would be the square root of 36 plus 4, so the square root of 40. Then we do the same thing to find the magnitude of v. Take the square root, square the first, square the second. 16 plus 64, which would be square root 80. And this is equal to cosine theta. So now we can just put all of this into our calculator. Alright, so when I put that in my calculator, I got cosine of theta is equal to 0.14142. Everybody agree? Okay. So how can I find theta? Take the inverse of cosine. So we click that cosine -1 of 0.14142. So I got 81.86. You guys agree with me there? Okay. Alright, so everybody's good with that one. Any questions there? Alright, we're doing the same thing for number 8. So we're using our same formula. Cosine theta is equal to the dot product over the magnitudes. First, we want to find the dot product. So we multiply the first times the first. That gives us 14 plus the second times the second. 8. What's 14 plus 8? 22. Now let's find our magnitude of u. So the magnitude, we take the square root, square the first, square the second. So this is 4 plus 64. We get the square root of 68. Now we have to find the magnitude of b. Take the square root of -7 squared plus 1 squared. So this gives us the square root of 50. So we plug it in. Cosine theta is equal to 22 over the magnitude of u, which is square root 68, times the square root of 50. So what do you guys get when you put this into your calculator? 0.97. What else? Give me more decimals.
Oh, I just wrote it down.
Okay. But this isn't the theta that we're looking for. We have to do the inverse. So what do you guys get when you took the inverse? What do you get for theta?
67.83.
67.83. Everybody agrees?
I got 14.0.
When I put this into my calculator, I got 0.377. Okay. So for the next two questions, we're working backwards to find what our dot product is. So we're using the same formula, but we're going to plug everything in that it gives us. So we have the cosine of 2 pi over 3 is equal to the dot product over 8 times 15. We have to figure out what the cosine of 2 pi over 3 is. How can we find that? Go to the unit circle. Cosine tells us we look at what value? The x value. So we have to find 2 pi over 3 on our unit circle and look at the x value. So this is -1/2. And that's equal to our dot product over 8 times 15, which is 120. Now we just want to solve for the dot product here. So if you want to write the dot product, if you want to just call it x, that's what we're trying to find. This top part here. So how can we solve for the dot product? Multiply each side by 120. So we get negative 120 over 2 is equal to the dot product. How can we simplify? Just divide by 2. So what do you guys get for the dot product? Negative 60 is equal to our dot product. Yes?
So you're gonna have a value that's not gonna be on the unit circle?
Alright, number 10. We do the same thing. So we have cosine of 5 pi over 6 is equal to the dot product over 7 times 22. So let's find the cosine of pi over 6. 5 pi over 6. 5 pi over 6 is here. We're looking at our x value, so that is negative square root 3 over 2. And 7 times 22 is 154. So the dot product over 154 is equal to negative square root 3 over 2. How do we solve for the dot product? Multiply both sides by 154. So you have negative 154 square root 3 over 2 is equal to the dot product. Can we simplify the left side? Yes, no, maybe? Can we simplify this?
Negative 77 times square root of 3.
Thank you. Negative 77 square root 3 is equal to the dot product. So that's our answer. Any questions here? Any questions on this page? For the last 3 questions, we just have to prove that the following vectors are parallel, orthogonal, or neither. So we have to check for parallel and orthogonal. If they both don't work, then it's neither. So let's start seeing if they're parallel. How can we check to see if our 2 vectors are parallel?
Did you put in a proportion?
A proportion. So we do the first over the first. So 6 over 5 is equal to the second over the second. Negative 5 over negative 6. Simplify to see if they're the same. Can't simplify 6 over 5, and then negative 5 over negative 6 simplifies to positive 5 over 6. Are these equal? Nope, so they are not parallel. Let's check if they are orthogonal. What do we need to see in order for them to be orthogonal? What do we have to do to check?
It needs to equal 0.
We need to take the dot product and see if it equals 0. So we multiply the first times the first, and the second times the second. So we get 30 plus, oh, this would be negative 5 times negative 5, so it's positive 30. 30 plus 30 is 60. Didn't get 0, so are they orthogonal? Nope. So then what are they?
Neither.
Neither. Alright, number 12. Let's check and see if they're parallel. So the first over the first, and then the second over the second. Simplify. How can we simplify negative 4 over 8? What does it simplify to?
Negative 1/2.
Negative 1/2. And then what about 7 over negative 14? What does it simplify to?
Negative 1/2.
Negative 1/2. So they are the same. They're proportional. Are they parallel? Yep, they're parallel. Once we know that they're parallel, you don't have to check to see if they're orthogonal, because if they're parallel, they're not going to be orthogonal. So then we're done. So let's go to 13. Let's check and see if they're parallel. So first over the first, second over the second. We can simplify our first fraction to 1/2, but we can't simplify the second. Are they parallel? Nope. Let's see if they're orthogonal. Take the dot product, first times first. That gives us 18 plus the second times the second. Negative 18. What's 18 plus negative 18? 0. Is that what we wanted? Yep. So they are
Yes.
orthogonal.